Welcome to Astronomy Daily, your daily dose of space and astronomy news. I'm your host, Anna, and today we've got an absolutely packed show covering some incredible developments across the space and astronomy world. From President Trump's bold vision of planting the American flag on Mars, to revolutionary new theories about how our moon formed, to groundbreaking research suggesting habitable worlds may have existed before the first galaxies, we'll explore it all. We'll also look at SpaceX's busy launch schedule, dive into fascinating new limits on dark matter, and examine the growing crisis of orbital debris. Stay with us for your complete update on everything happening in space exploration and astronomy. Let's get started with today's news. In a striking return to the political stage, former President Donald Trump has laid out an ambitious vision for America's future in space, specifically targeting Mars as the next frontier for American exploration. During his inauguration speech as the 47th president, Trump declared that the United States would pursue what he called our manifest destiny into the stars, with the ultimate goal of planting the American flag on the red planet. This bold proclamation garnered immediate attention from key players in the space industry, including SpaceX CEO Elon Musk, who was present at the inauguration and showed clear enthusiasm for the announcement. It's worth noting that this aligns well with Musk's own long-stated goal of establishing a human presence on Mars. The timing of this announcement is particularly interesting given recent developments in space technology. SpaceX has just completed its 7th test flight of the Starship rocket system, which, despite ending in an explosion, achieved several crucial milestones, including the successful landing and capture of its Super Heavy booster. This vehicle is currently our most promising candidate for future Mars missions. The private space sector is showing remarkable progress, with Blue Origin also recently achieving success with their New Glenn rocket's first orbital launch. NASA has already contracted both companies for various missions, with SpaceX's Starship selected for lunar landings and Blue Origin's New Glenn scheduled to launch the next robotic mission to Mars. However, the path to Mars remains challenging. Current timelines suggest the earliest uncrewed missions to Mars might launch in 2026, with human missions following years later. The technical hurdles are substantial, from radiation protection to landing systems capable of safely delivering large payloads to the Martian surface. Trump's vision of American astronauts on Mars represents perhaps the most ambitious space exploration goal since the Apollo program. Whether this vision can become reality will depend largely on sustained funding, technological advancement, and continued cooperation between government agencies and private space companies in the years ahead. Next up today, a groundbreaking new study from researchers at the University of Gottingen and the Max Planck Institute for Solar System Research has challenged our long-held understanding of how the moon formed. Through detailed analysis of lunar samples and Earth minerals, they've discovered evidence suggesting that our moon likely originated primarily from Earth's own mantle, rather than from a cosmic collision with a Mars-sized object called Theia, as previously believed. The team conducted an extensive examination of oxygen isotopes in 14 lunar samples and performed nearly 200 measurements on Earth minerals. What they found was remarkable: an exceptionally close match between Earth and Moon samples for a specific isotope called oxygen-17. This similarity has long puzzled scientists, who even dubbed it the isotope crisis, because it seemed to contradict the prevailing theory of the moon's formation. To explain these findings, researchers propose that the hypothetical planet Theia may have lost its rocky mantle in earlier collisions before impacting Earth. They suggest it essentially hit our planet like a metallic cannonball, becoming part of Earth's core while ejecting material from Earth's mantle that would eventually form the moon. This new model elegantly explains why the moon's composition so closely mirrors Earth's, but perhaps even more intriguing are the implications this discovery has for Earth's water. The conventional wisdom has been that Earth received its water later, through a series of asteroid impacts after the moon formed. However, the new isotope data suggests otherwise. The research team found that certain meteorites called enstatite chondrites could have been solely responsible for Earth's water, indicating our planet may have been wet from the very beginning. These findings fundamentally reshape our understanding of both lunar formation and Earth's early history. They suggest that rather than being the product of a cosmic accident, Our moon might be more accurately described as a direct offspring of Earth itself, carrying with it a piece of our planet's primordial story. Now, let's take a look at this week's SpaceX launch schedule. Following SpaceX's dramatic week with the Starship test flight, the company is maintaining its ambitious pace with an impressive lineup of 4 Starlink missions scheduled for the coming days. These launches mark the continuation of SpaceX's efforts to deploy their internet constellation, with nearly 3,000 satellites currently in orbit. SpaceX has recently unveiled an upgraded version of their Starlink satellites, featuring a significant weight reduction of 22% compared to the previous design. This optimization allows each Falcon 9 rocket to carry more satellites per launch, improving the efficiency of their deployment strategy. The latest version weighs in at approximately 575 kilograms, a notable improvement that could enable launches of up to 27 satellites at once. The first launch of the week will kick off Group 13 from Kennedy Space Center, carrying 21 satellites, including 13 equipped with direct-to-cell capabilities. This will be followed by the Group 11, 8 mission from Vandenberg Space Force Base, featuring 27 of the lighter satellites. 2 more launches are scheduled later in the week, maintaining SpaceX's remarkable launch cadence. These missions aren't just about numbers. They represent significant progress toward SpaceX's goal of launching approximately 7,500 V2 mini Starlink satellites. Of the nearly 3,000 satellites launched so far, about 97 have completed their missions and deorbited, demonstrating the company's commitment to responsible space operations. What's particularly noteworthy about this intensive launch schedule is how routine these missions have become. The Falcon 9 rockets being used are proven workhorses, with some boosters having completed up to 25 flights. This reusability has been key to maintaining such an aggressive launch schedule while keeping costs manageable. These launches will continue to expand global internet coverage, bringing connectivity to previously underserved areas around the world. Here's one of those stories that come along from time to time that have the potential to rewrite the textbook. In what could be one of the most fascinating revelations about our universe's timeline, new research suggests that habitable worlds might have existed long before we thought possible, even before the first galaxies formed. This challenges everything we thought we knew about the sequence of cosmic evolution. The conventional wisdom has always been clear. First came the Big Bang, then the first stars and galaxies, and only after that could rocky, potentially habitable planets form. This made sense because the early universe contained only the lightest elements, hydrogen and helium, with just traces of lithium. The heavier elements needed for rocky planets simply didn't exist yet. But researchers from the University of Portsmouth have presented a compelling alternative scenario. Their work suggests that the very first stars, massive and short-lived, might have been the key. These stars, known as population 3 stars, exploded as primordial supernovae, creating the first heavy elements in the universe. What makes this theory particularly intriguing is the timing. According to their simulations, when these early supernovae exploded, they enriched their surrounding space with heavy elements like carbon, oxygen, and iron, the building blocks of rocky planets. In the aftermath of these explosions, smaller stars could have formed, and around them, the first potentially habitable worlds. The researchers' models show that these early planetary systems might have contained amounts of water similar to what we see in our own solar system. All the ingredients necessary for life as we know it could have been present in these ancient solar systems, long before the first galaxies had fully assembled. If this theory proves correct, it would dramatically expand our search window for potentially habitable worlds. We might need to look for signs of ancient planets around some of the oldest, most metal-poor stars in our galaxy. Literal cosmic fossils that could tell us about the very first chapters of our universe's story. While this remains theoretical for now, it opens up exciting new possibilities about when and where life might have first emerged in our universe. It suggests that the cosmic conditions necessary for life might have been present far earlier than we ever imagined, fundamentally changing our perspective on the timeline of potential life in the universe. Moving on to another puzzle. Dark matter continues to be one of the most perplexing mysteries in modern cosmology, and now scientists have discovered another fascinating wrinkle in this cosmic puzzle. New research suggests that dark matter particles can't be too heavy, or they would essentially break our best model of how the universe works. We've known for decades that something invisible is affecting the motion of stars and galaxies. Stars orbit too quickly within galaxies. Galaxies move too fast within clusters, and cosmic structures grow and evolve more rapidly than they should based on the visible matter we can detect. This invisible influence is what we call dark matter, and it appears to make up most of the mass in our universe. Despite numerous attempts to detect it, dark matter has remained stubbornly elusive. Most experiments have focused on searching for particles with masses between 10 and 1,000 giga-electron volts, roughly in the range of the heaviest known particles like the W boson and top quark. But with no successful detections, scientists have begun wondering if we should be looking for something much lighter or heavier. However, new research has revealed an unexpected constraint. It turns out that if dark matter particles were too massive, they would create serious problems with our understanding of the Higgs boson, the particle that gives other particles their mass. The interactions between heavy dark matter and the Higgs would fundamentally alter the Higgs boson's properties away from what we observe, essentially breaking down the mechanisms that make particle physics work. This discovery is particularly significant because it helps narrow down our search. While we still don't know exactly what dark matter is, we now have a better idea of what it can't be. This could lead us to focus more attention on lighter particles, such as axions, which are becoming increasingly attractive candidates for dark matter. The findings also demonstrate how interconnected our understanding of the universe is. We can't simply make dark matter arbitrarily heavy without considering how it would affect other fundamental aspects of physics. This interconnectedness provides valuable constraints that can help guide our search for this mysterious substance that makes up roughly 85% of all matter in the universe. Finally, today, the growing problem of space debris has reached a critical point, with scientists now calling for unprecedented international action. An international research team, including experts from NASA's Jet Propulsion Laboratory, is urging the United Nations to add the protection of Earth's orbit to its sustainable development goals, marking a significant shift in how we approach space sustainability. The situation has become particularly urgent with the rise of mega constellations. Just 15 years ago, we had barely 1,000 satellites orbiting Earth. Today, that number has exploded to more than 10,000, and it's still climbing rapidly. As these satellites reach the end of their operational lives, they don't simply disappear. They become potential hazards in our orbital highways. The numbers are staggering. We're currently tracking over 40,000 pieces of debris larger than 4 inches, more than 1 million pieces between half an inch and 4 inches, and an estimated 130 million tiny fragments smaller than half an inch. These objects aren't just floating peacefully. They're hurtling around our planet at speeds of nearly 5 miles per second, making them potential catastrophic threats to active satellites and spacecraft. Experts are increasingly concerned about a phenomenon known as Kessler syndrome, a cascading effect where collisions between objects in orbit create more debris, which in turn causes more collisions. Some scientists believe this destructive cycle may already be beginning. The problem isn't just about space. These satellites don't stay in orbit forever. When they fall back to Earth and burn up in the atmosphere, they release aluminum oxide, which can damage our ozone layer and affect Earth's ability to reflect sunlight. This could potentially undermine decades of environmental protection efforts and worsen climate change. Drawing parallels with ocean pollution, researchers suggest we can apply lessons learned from managing marine debris to prevent a similar crisis in orbit. Just as we once viewed oceans as infinite resources that could absorb endless waste, we're now realizing that space isn't the limitless frontier we once imagined. It's a finite resource that requires careful management and protection. The call for UN intervention represents a critical step toward establishing international frameworks for space sustainability. Without coordinated global action, we risk turning Earth's orbit into an unusable junkyard, potentially cutting ourselves off from the very space-based services we've come to rely on in our daily lives. Well, that's all for today's episode of Astronomy Daily. I'm Anna, and I want to thank you for joining me on this journey through the latest developments in space and astronomy. If you'd like to stay up to date with all things space, visit us at astronomydaily.io, where you can sign up for our free daily newsletter and catch up on all the latest space and astronomy news with our constantly updating newsfeed. You'll also find all our previous episodes available for listening anytime. Want to connect with us on social media? You can find us as Astro Daily Pod on Facebook, X, YouTube, YouTube Music, Tumblr, and TikTok. Until tomorrow, keep looking up and stay curious about our amazing universe.